So there are three properties of logarithms that are kind of key properties, I guess. They're really important. And they are these guys right here. Product property, quotient property, power property. So the product property says you can take the log of two things multiplied together and actually split it up as the sum of two logs. And notice it's the same base. So it's basically the same as saying that if you have like x squared times x cubed, you can add those two exponents and get x to the fifth. So to have kind of similar letters, we might write something like b to the x times b to the y is equivalent to b to the x plus y. So remember, a logarithm is an exponent, so it behaves in similar ways to exponents. So then the quotient property is similar, and so this is kind of like how if you have, I don't know, say x to the fifth over x squared, you can cancel stuff, right? And so one way to think of it is you can just actually subtract the exponents. So this is the same as x to the 5 minus 2, or x cubed. And so the way it would look with kind of similar letters there is if you have b to the x over b to the y, that's the same as writing b to the x minus y. And then so finally the last one is if you have something like x squared to the fourth power. Then we know that we can multiply those two exponents together, and this is the same as x to the eighth. And so here, if we use similar letters, it's like if we have b to the x power, and then we raise that to another exponent, you can actually multiply these together. And so how it works in the log is that if you have inside your logarithm, you have something, everything in the logarithm is raised to some exponent, you can actually bring that out front as a coefficient. It's kind of crazy that it works like that. So that's what's going to come into play with this topic, using properties of logarithms to evaluate expressions. So we, first off, we kind of want to make sure that everything has the same base, and it's going to. So for part A, everything's base 6. And I noticed that I happen to have two logarithms added together, two log base 6s. So at some point, because it's added together, I'm probably going to need to do the product property to combine this into a single logarithm. Before I do that, though, I have to do something with this 2 on the outside. So whenever you have, so p times log base whatever of x, whatever it is, you can bring that p inside the log as an exponent. So this is kind of the opposite way that it was written in our notes. So that's the first thing I'm going to do here. So I'm going to write the log base 6 of 9, let's just let that hang out, and then plus log base 6 of 2 squared, which of course is 4, so we can write that. So we now have log base 6 of 9. I'm being kind of inconsistent with my parentheses, plus log base 6 of 4. And so now we're going to use the product property in reverse. So the product property says if you have log base b of something plus log base b of something else, you can write this as a single logarithm with the two things multiplied together. So multiplying 9 times 4, this is the same as log base 6 of 9 times 4 is 36. Okay, so we've got this down to a single logarithm, and I'm kind of like, okay, this is going to work because 36 is a power of the base 6. So a logarithm is an exponent. So if we think about 6 to the what power would give us 36, well, it would be 6 squared. So this is 2 after all of that. So now let's look at this guy down here. So this guy, we actually could do this one in two different ways. So it's already got part B here. We've already got everything inside the log. We don't have any coefficients like we did in part A to kind of bring inside. It would be very tempting maybe to, well, actually we could do it that way too. Okay, there's like 3 different ways we could do part B. So here, I'll just go ahead and start talking about it. Natural log of e to the 8th power is just 8, right? Is the log base e of e to the something. You could even put it in your calculator. This really is just equal to 8 minus 2 or 6. So yay. You can also, though, you could use the power rule to bring the 8 out front and write this as 8 times the natural log of e minus then 2 times natural log of e. But natural log of e equals 1, right? E to what gives us e? Well, it's just 1, right? Base matches what's inside. So this is 8 minus 2 again, or 6. So that's method number 2. So then the other way is, because this is a minus, we could combine this into a single log using the quotient property. So natural log of the first thing, the first argument, e to the 8th, over the second argument, e squared. And then we could simplify that. This is probably the hardest way, or the most roundabout. We could simplify that by just canceling e squared or subtracting exponents so that we have natural log of e to the 6th power. But now that's just 6. So lots of different ways to get 6.